Okay, welcome to part 2 of our online snow day lecture slides. Um, as soon as we are done talking about nuclear, our next topic in Module 5 is the topic of renewable energy. So what I want to do in this current slideshow is just talk to you about the type of renewable energy that you are probably the most familiar with, which is photovoltaic solar energy, or PV solar energy. In class next week, we'll also talk about some other ways to harness the sun's energy, but this will give us a little bit of a leg up so we can already have talked about a few things and we will have enough time. So photovoltaic you probably know as PV. These are the solar panels that you see on people's roofs around Albany, and we'll talk a little bit about why you see them so prominently. So the thing that distinguishes PV energy is that there's no moving parts, and these panels convert sunlight directly into electricity. And once they're built, they are emission-free. PV devices use semiconductor technology, and we are not going to talk about how semiconductors are used to turn sunlight into electricity, but if you are interested in that, there's a pretty nice discussion on those pages of your book. All right, so you have probably all seen things that look like this, whether you've seen them all in an array field, like what's shown here, or just on the roof of small-scale houses. This is what a PV panel looks like. So each one of these PV panels collects a tiny little bit of electricity, and we wire them all up together, and we hook them onto the grid also known as the wires that connect to your house, that bring electricity into your house. And that uploads electricity onto the grid in much the same way that a coal power plant uploads electricity to the grid. A use of PV that's been in use for a really long time, much earlier than the wide-scale use of it as a sort of an alternative to electricity, has always been the idea of remote PV. So you can bring a seismometer up to the pit of a volcano and power what it needs to have operating with a solar PV panel, and you don't need to have wires power lines that go to the inside of that volcano in order to be able to do it. You also don't need to bring a very heavy battery up to the top of your mountain. And as someone who has lugged a very heavy battery up to the top of a mountain, I will vouch that that's an extra 50 pounds that would have been nice to not have to carry. We see these around town as well. There is a school speed limit sign that is a solar powered on Hackett right before you turn onto Academy Road that I drive by just about every day on my way to work. You'll also see a lot of these on construction work projects. So they'll have little trailers that can show you when the bridge is closed ahead and they don't need to be wired up. And that last picture in the bottom right-hand corner, I think, is a picture of a buoy out in the ocean, where again, you obviously don't have the ability to bring power lines all the way out to the middle of a buoy. So we've been using this technology for a really long time. But until recently, it's been not used hardly at all as a way to get electricity into houses. So here is a plot of how much our PV installed capacity has gone up in recent years. And you can see this plot doesn't include 2015 or 2016 yet, but it's continued to go up in much the same way. We're going up more and more each year in huge amounts. But I do want to draw your attention to the y-axis there. So our current installed PV capacity, we'll just say, is about 200,000 megawatts. That is equivalent to fewer coal plants than you might believe. So we'll talk about that a little bit in the future. But while we're going up a lot with PV capacity, it still is a very, very small fraction of our actual capacity for electricity generation in the world. And in here is our growth. So our current installed capacity is, in this figure, is 150 gigawatts or so. So that was, I said it was 200,000 megawatts in the previous slide, and this is saying it's more like 150,000 megawatts. Different numbers happen from pulling from different sources, but those things are kind of ballpark estimates of different things. And just to compare, a large coal or natural gas plant is about 1 gigawatt. So we sort of have the current capacity of 150 or 200 coal plants in solar throughout the world. The world's largest power plant that gets its energy from the sun is actually not a PV plant. It's a CSP plant. That stands for Concentrated Solar Power, which we'll talk about in class next week. But just to compare that, that's a 19 megawatt plant. So it's a much smaller amount of electricity generated even from giant solar plants than we get from a single traditional power plant. But this is going up. There's an estimate from 2020, which may or may not end up being exactly what ends up happening. But you can see that we're investing heavily worldwide in solar energy. All right, so there's a lot of reasons why solar energy was nice. So we've spent, I don't know, the past 5 or 6 weeks talking about fossil fuels and nuclear, and there's a lot of downsides to fossil fuels and nuclear. Fossil fuels in particular are a finite resource that we are running out of, and they have a lot of negative environmental impacts associated with them. Coal is extremely dirty when you burn it. Gas and oil are fairly dirty when you burn it, but also a lot of the unconventional techniques that we use to extract them are really harmful. And this is, of course, compounded by the fact that we're running out of all of them. And so, we have to eventually shift away from those resources. So in huge contrast to problems with the fossil fuel and nuclear industry, or I guess mostly in contrast to the fossil fuel industry, once this is built, it's clean. You don't have to worry about emissions. You don't have to worry about a nuclear meltdown. You don't have to worry about any of that things. Also, once it's built, it's sustainable. And a big one here is once it's built, it's free. So your investment in solar energy is all going to be an investment in the infrastructure and the solar panels to set everything up. And a very minimal investment goes into maintaining the panels and getting those things up onto the grid. We also can provide electricity into remote places. And a sort of unexpected nice thing about solar energy is when we get it. So if you think about it, when do we get most of our solar energy? When is the sun shining the brightest? It shines the brightest in the middle of the day. That's also at the same time that we're using the most energy. So solar, while it is an intermittent resource, right? The sun doesn't shine at night, and that can be a problem with solar. It actually tends to maximize in the middle of the day. And even more so than that, in a couple of weeks, we'll talk about the electricity grid and the problems associated with the way that we deliver electricity to households. But one thing that we're going to learn is that we build our power plants and our energy grid to meet the demand of the United States or a region on the hottest day of the year. That's when we call it the peak energy demand is. That's when all the blackouts happen. We use the most energy on the hottest day of the year. So we build all of our infrastructure to be able to supply that much energy on the hottest day of the year. Every other day in the year, we don't use that much electricity, but we still have the capacity to produce that much electricity. So there's a lot of extra infrastructure that doesn't actually need to exist, except for the days of the year when it is the hottest. And this is a nice use of solar in a way that it's currently being used in a lot of ways, in a lot of places, where you don't, where the solar produces the most electricity on that peak demand day, on that day of the year when we have the hottest day of the year. It's also the sunniest. So solar can kind of help us meet our peak demand needs in the heat of the day. So next I want to talk about some disadvantages of solar. And I think the things here in parentheses are foreshadowing a lot of that stuff. Let's talk about them. Is that the manufacture and disposal of solar panels is probably not awful if you want to compare it to mountaintop coal removal, but it's definitely something that you need to be concerned about. The semiconductor industry involves lots of toxins, and so that manufacture and disposal is definitely not a clean process. And also, while it can help us meet our peak energy demand on that hottest day of the year, it has what I'm going to call an intermittency problem. And this intermittency problem is going to pop up again and again when we talk about renewables, right? The sun is not always shining, the wind is not always blowing. It's part-time. And as of right now, we really have no viable large-scale storage way to store this energy. So when the sun goes down, that source of electricity is gone. And we need something else to supply our energy when the sun isn't there. Its reliability depends a lot on location. So we in New York State have a much weaker solar resource than they do in the desert Southwest because we just see less sun over the course of the year. Also, the footprint of these plants is enormous. So even, I will show you a picture next time of that largest solar plant in the world, and you'll see how giant it is. You know, tens, 20s, hundreds of acres go into producing relatively small amounts of electricity if you want to compare how much the sort of land footprint is of a traditional power plant. And a big one, although this is becoming less and less of an issue as technology gets better and better, is that usually solar electricity is more expensive than fossil fuel electricity. And when it all comes down to it, people will buy whatever is the cheapest. And that gets us to the question of what's called an energy payback time, which is that I said that, you know, solar energy is free once it's built, but it actually is a large initial investment to build your solar panel. So that's what is called the energy payback time. So for example, an energy payback time of 1 year would be that you paid 1 year's worth of electricity bills to build the structure, and then you got free electricity after that. So it sort of took you 1 year to break even, right? You sort of paid a 1 year upfront cost, but then you didn't have to pay anything after that. So everything that you do after 1 year is a cost savings. So that would be an example of what a 1 year energy payback time was. The energy payback time for solar panels is much more than that, though it is becoming less and less and less. So the way that all of these things always work is that the more research and development that goes into it, the more cost effective the building of the panels gets. Also, the more people who have solar panels, the more automated the building process gets and the cheaper that whole sort of manufacturing process gets as well. So it does have a somewhat long energy payback time of, it varies widely. but sort of that is getting better as time goes on. Okay, so why don't we have solar energy everywhere? What do you think is the biggest reason why it's not being used? Here's what I would argue is that when you take into account all of those things going on in the previous page, so the manufacturer costs money and the energy payback time and the initial investment to get all of this stuff up and running, the purchasing of the land to put the solar panels or the leasing of the land to put the solar panels, all of that stuff means that solar energy costs more than fossil fuel energy does. And people aren't going to pay for more solar energy than they're going to pay for the fossil fuel energy. I should add that these numbers are for 2011, so it's from the Department of Energy, so it may or may not have changed a little bit since then, but this gives you a pretty good idea. So if we want people to buy solar energy, we have to do something. And the only thing, the best thing that we know how to do is to use something called subsidies. So this is the idea that you pay people to use solar instead of fossil fuels. That may seem like a really weird thing to do, right? Why would I pay somebody to do something? I should make the market do it. And whether or not you agree with subsidies probably gets to the heart of some of your political opinions or things like that. I would say, though, and this is what the graph on the right is, this is the budget for research programs that invest in different types of energies. So this is the United States budget for subsidies, basically. And you can see that fossil fuels and nuclear energy is way more subsidized than any other renewable energy is. So whether or not you agree with subsidies is sort of a separate issue. We currently do subsidize fossil fuel and nuclear way more than we subsidize renewable energies. Another example of a subsidy is that New York State currently has incentives to encourage solar development. So this is another example of a subsidy. And this is why you have seen so many solar panels on the roof of your house. So an example of a subsidy is the idea of net metering. And this is what's going on in New York State right now. So here's a photograph from your textbook. This where Wolfson says that this home produces more electricity than it uses, and it sells the excess to the local power company. So this is the idea of net metering. And I have a video that I would like for you to watch, and I've included a link here, and also if that link is pretty difficult to type in, you can also find it on a Google search. It's the top hit if you type in solar net metering 101 for residential. You don't have to watch the whole video unless you're really interested in it. Go on to the 4 minutes and 45-second mark, and then you can stop. And I'll give you just a minute to do that. And when you come back, we'll go to the next slide. All right, so hopefully you have watched that video. And I just want to give a quick overview of, the 3-sentence overview of what net metering is. In net metering, your roof, solar panels are placed on your roof, and those solar panels are hooked up directly to the grid. So some people are even somewhat surprised by this, but that electricity is actually being produced at your house, but is not actually going to your house. It's going to the grid. So you're getting credits from the utility company for putting electricity onto the grid. And when you pull electricity down from the grid, then you use up those credits. So what you would like to do with a net metering system is do some sort of way where if you are using 100 kilowatt hours of electricity in your house, if you are if you're uploading 100 kilowatt hours of electricity onto the grid, then you sort of are getting 100 credits for your upload, and you're getting 100 credits for free for having done that. Some people are sometimes surprised to learn that a house with solar panels on it that's participating in net metering, when the power goes out, they still lose their power. Their solar panels are not hooked up to their house. Their solar panels are hooked up to the grid. It's just sort of a very spread out way of uploading electricity onto the grid. So net metering is becoming more and more, and most of the increases in net metering are having to do with incentives that are happening. So we in New York State are absolutely not a mecca for solar energy, but we have huge growth in solar energy recently, and this is all due to subsidies that are associated with net metering that we'll talk about in a couple of minutes. So I want to show this and just give you a minute to look at it. So the red is where there is no net metering available to any sector. The green is where net metering is available in some form or another, and the gray is where there's really no policy on net metering. And I just want to give you a minute to look at that and think about why you think different places have these policies. As you're thinking about it, try to think about where the solar resource would be the best and see if you think those match up with where the green and the red are. So for me, what I see here is absolutely not a map of where the solar resource is the best. The sun shines the best in dry places like the desert Southwest, and it also shines the best farther south. So why are New York State, Maine, Oregon, and Washington net metering states, but Florida and New Mexico aren't? And that all comes down to politics. So some states are, and I shouldn't even call it politics, I should call it, sort of the environment of the state, whether or not they're willing to subsidize this sort of thing. Next time when we meet, I'd like to have a quick discussion of why you think states might not allow net metering. Like what would be the reason why they wouldn't like to have net metering in their state? So if you could think about that and come with a couple of ideas when we meet next time, we'll start with that at the beginning. All right, so here in New York, we are currently a net metering state, so we allow it and we regulate it. So if you put solar panels on your roof, you can sell all that electricity back to the power company, and you get credits in the form of getting credits off of your electricity bill at retail prices. We also have some tax incentives. So federally, so this is everywhere in the U.S., there's a tax credit that is 30% of the cost of installation of any solar rooftop operation that you get back on your tax return. Also, a quarter of that installation cost is tax deductible. Just to kind of give you a little refresher on tax credits versus tax deductions, that credit is actually money that you get back. So if your solar installation costs you $9,000, then you'd pay $9,000, but come April, when you fill out your taxes, you'd get $3,000 of that back. A tax deductible is not something that you necessarily get all the way back. A tax deduction is something that you get a portion of that back depending on how much taxes you pay. We also have in New York State another incentive that typically costs 20 to 30% of the installed costs, and an advantage of that is that those costs go directly to the contractor, so it's not something that you have to pay up front and then get reimbursed for come next spring. So the net effect of all of these tax incentives, also known as subsidies, is that our local solar has increased dramatically. So this is just 2 years, and you can see that our residential has gone up dramatically. And so I think if we were polling the whole class here, we would see that probably none of you have solar panels on the roof of your house. I know we have a few homeowners here, so that may not be the case. But usually this class is populated by students. And students tend to rent. They don't tend to own their house. I know that when I was a student, I didn't own my house. And it makes no sense for you as a student to do some sort of long-term investment in your house that will save you money over the course of 5 to 10 years, but is a large initial investment. So net metering as it is right now is really something that is focused heavily on where we are as on residential homeowners to lower their electricity costs. And unfortunately, it's not something that is available to renters or low-income people or things like that. And that will hopefully change a little bit going into the future with the idea of remote net metering, which we'll talk about next time. And that's where I want to leave this today. And we'll pick up this idea and remember talk about some reasons why maybe net metering wouldn't be super great for people that aren't necessarily the residential customers, and pick this up next week.